ZL-105, the new cancer drug. ZL-105 has many better effects than other cancer drugs out today. It pushes cancer cells to the limit, forcing them to shut down. Normal cells can cope with the effects and not be harmed. A new catalyst that attacks the cancer cells slows the growth of tumors. What it treats. ZL-105 treats many different types of cancer: breast cancer, ovarian cancer, colon cancer, prostate cancer, and even melanoma. To the right, you'll see a picture of a normal prostate and a large prostate. This is one of the things it'll treat. How it works. This drug is made up from precious metal iridium. It attacks cancer cells like an enzyme. The catalyst speeds up the cancer cell till it overrides itself. It attacks in multiple ways at the same time. Cancer cells do not get used to it, so it does not lose its toxicity. Positives. Works up to 10 times better than older cancer drugs out there. It is cheaper to produce than other platinum-based cancer drugs. Lasts longer and has greater effects over time. Does not damage any other cells in this process. Protects DNA cells instead of harming them. Dramatically slows down the growth and can even stop cancer growth. Significantly reduced side effects compared to other cancer drugs. Trials. It is being used in combination with chemotherapy to stop prostate cancer. Survival among patients with the most advanced prostate cancer has increased. The combination has extended 3-year survival rates from 52.5% to 69%. FDA approved and has been tested with success, slowly making its way to the market in America. Studies show it works the best with prostate and ovarian cancer. Below you can see a prostate gland. The reason I chose this topic is that my grandfather died of prostate cancer. If this drug was around when he was alive, he would have had a better chance of surviving longer. It may have even saved his life. Next, I have a YouTube video which explains the drug itself a lot better than I do. I'll play that now.
Slowly coming into focus under a microscope, these are ovarian cancer cells. And ovarian cancer has a particularly nasty trick which chemists at the University of Warwick are trying to overcome. So these are ovarian cancer cells. This is what they've been using in the lab, and they're really interested in these because there's such a problem with resistance in ovarian cancer. If you have ovarian cancer and you relapse, when you go back to hospital, 80% of patients will have developed a resistance to the chemotherapy drugs. Half of all cancer treatments use cisplatin, and resistance is a real problem. But ZL-105 is a new drug designed to work in a new way and avoid the problems of drug resistance.
We are aiming to attack the cancer cell in many different ways, because if we attack the cancer cell in different ways, it will not have enough time to learn what is happening to it, and it won't react. It's more difficult for the cancer cell to develop resistance to that particular drug.
ZL-105 has only been tested in the laboratory, but we know it kills cancer cells. In this tray, cancer cells have been dyed purple. The lighter the colour, the fewer cancer cells remain after treatment with various strengths of the new drug. But getting a drug from lab to hospital bed is expensive and does take time.
I am excited, and I have to be optimistic. I'm at the very early stage, but I've developed, and my team have developed, totally new chemistry for attacking cancer cells. It is complicated, the chemistry inside the cancer cell. We need new methods and new techniques for studying these drugs inside cancer cells. But we must be optimistic. There is a need for new drugs in the clinic that work by different mechanisms, and we're excited about that.
It's a totally new approach, and so far it's looking very promising. David Gregory Kumar, BBC Midlands Today at the University of Warwick.
This is my works cited page, shows the sites that I used to find my information for my report. I would also like to thank my teacher for the great job that he did teaching this class and all of the information he gave us.